So welcome all. So in this video we will discuss about the sorting of numbers and using ALP program. Okay. So now this is in continuation with the bit manipulation instruction program. Right. Now coming to the sorting. So what is meant by sorting of sorting? Sorting is the arrangement of numbers either in ascending order or descending order. So we have many algorithms for this sorting of the numbers, but we'll take the simplest one known as bubble sort for implementing it. Okay, so bubble sort is otherwise known as a exchange sort. Okay, and it completely depends upon the swapping of the two numbers. Okay, so it's repeatedly stepping through the list to be sorted and comparing two items at a time and swapping them if they are in the wrong order. Okay. Now we will illustrate this with the help of a simple example. So let us take five numbers which are to be sorted out, which are located at five memory locations: M1, M2, M3, M4, and M5. Okay, the five numbers are, let us consider 40, 50, 30, 20, and 10 respectively, located from M1 to M1 through M5. Okay, so the bubble start will start from like this. Okay, so at the starting, the first data, the data that is present at the first location and the data that is present at the second location are compared. Okay, so if the first data is lesser than the first data is greater than the second data, then the data is going to be exchanged. Okay, if it is less than the second data, the data exchange will not be performed. So now let us illustrate this with the help of this same example. Okay, so out of this 40 and 50 at this initial stage, out of this 40 and 50, 40 is the smallest number and 50 is the largest number. So the data swapping or data exchanging will not occur. So then next, the control is shifted to the memory location M2 and M3. Now the comparison is performed between 50 and 30. So since 30 is less than the 50, the previous location, the data gets exchanged and the new data is, the data is rearranged as 40, 30, 50, 20 and 10. And now the control is again transferred to the next location right from 50 to 20. Okay. So now 50 is compared with 20 and obviously 20 is less than your 50, so the data gets exchanged and the new data arrangement will be 40, 30, 20, 50 and 10. Okay, next again 50 and 10 are going to be compared and out of this 10 is the smallest number, so the data gets exchanged and the new data format will be 40, 30, 20, 10 and 50. Okay, so now if you see, after completing one complete cycle, we will get the largest number at the last location. Okay, and largest number at the last location, and now leftover are four numbers. So in order we have to sort this four numbers. Again we start the same procedure. We start from the starting. So now 40 is compared with 30, the new arrangement of data. So 30 is smaller, so both will get exchanged and the new arrangement will be 40, 30, 40, 20. Again 20 is less than your 40, so these both will get exchanged and the new data arrangement will be 30, 20, 40 and 10. Now 40 and 10 are compared and the new data will, since 10 is less than 40, both will be get exchanged for 30, 20, 10, 40, and 40 and 50 are compared again. Since 50 is the largest number in the array or in the data, so there is no need to compare it again. Okay, so now the new data arrangement will be 30, 20, 10, 40 and 50. Okay, now the data will be 30, 20, 10, 40, 50, and 30 and 20 are get compared. So 30 and 20 are compared. So since 20 is less than 30, then we'll get 20, 30, 10. So now 10 and 30 are get exchanged, and 20, 10, 30, 40, 50 will get. Okay, so like this, the comparisons will go on, and by the end of the all comparisons, we will get a sorted array in terms of 10, 20, 30, 40, 50. And this is the logic we are following for arranging the numbers in ascending order. If you do it in reverse, means the exchange operation is in reverse operation. That is, if first data and second data are compared, and if second data is greater than the first data, perform the exchange operation, then we will get the descending order operation. Uh, Descending order data elements. Okay, so just one small comparison. So if we are exchanging for the smallest number, we will get the ascending order, and if we are exchanging for the largest number, we will be getting the descending order. Okay, now coming to the program, implementing this program in the uh, uh, for ARM32 Cortex boards. Okay, so first we will be defining the area list data read only. So a memory location is being allotted, and it is named as list, and it is defined as a data segment, and we can access only the data from it. Okay, so we are going to store the data in that. So the data is stored in terms of a double word. So we are using uh, define code double word. Okay, and each and every data is going to consume 4 memory locations. Okay, so one location 8 bits, 8 bits, so totally 32. Okay, so totally for the complete list it is going to consume 20 memory locations, right? And we are going to align them, properly. And similar to that, we are going to define a destination location where we will be performing all these operations, all these operations. So 10 locations, we are reserving some space for performing the operations for our for the ascending order. Okay, so 10 spaces are being allocated in the destination location. Next, we are defining the length of the data set as 5 and length equal to 5. Okay, so this is how the data set will be. This will be the length of the data set. Okay. Next, coming to the code memory. So we are defining the code memory. We are defining the code memory in which we are writing the program. So first we will initialize R0 with the length R5. So first we will do the copying process from the list. The data is being will be copied from the list to the destination. Okay, so for this copying process, we'll use the normal method. LDR. So first we will initialize the length to R0 register. Then the starting address of the list is assigned to R5, and the starting address of the destination we are assigning to R6. We are assigning to R6. Okay. Then we are adding So first R5. So see here. So first R5 is pointed with so R5 and R6 points to the starting location of the list and the destination respectively. Then the data which is being accessed by pointed by R5 is moved to R1, and this R1 data is stored back to R6, means from source to destination we are copying. So this is the instructions. LDR will copy the data to R1, and STR will store the data from R1 to the point loaded to R6. Okay, then the next data has to be copied. So for that, what we do is we will add +4 for R5 as well as R6 registers. Why we are adding four? Look, four is because one data is going to consume four locations. Okay, so when we try to copy R5 to R1, only the first location is going to get copied. The remaining three will be as usual. So we have to come to the last position. So we are adding 4 to R5 and 4 to R6. Okay. Then we are subtracting R0 by 1. So one data has been copied. Right. So again, we are comparing it with 0. And since branch not equal, so if R0 is not equal to R0, immediately we are going for the next copying procedure. So uh, by the end of R0 becoming 0, all the 5 data will be copied to the destination. Now the next part is our implementation of first copying is done. Now we are going to implement the bubble sort logic. So first LDR, as usual, we are going to initialize R0 with 5, the length of the data set. Then R6 is pointed to the destination, the starting address of the destination. And again, R1, we are going to take another counter register, R1, and we are making that as 5 again. 5. And we are subtracting R1 by 1 factor. So now R1 value will be 4 and R0 value will be 5. Okay. Next, we are moving the starting data that is pointed by R6 to R2, right? And then we are adding 4 to that, and then the next data, that is first 8F is moved to R2, and then 12 is moved to R3. Then we are performing the comparison operation R2 comma R3. Okay, so if you do this R2 comma R3, if the first data is greater than the second data for ascending order, the data has to get exchanged. Okay, so the first data R2 is 8F is greater than 12, so it has to get exchanged. So this condition will fail. So R2 is greater, so this condition will fail and the exchange will occur. So R6 will be moved to R2, and R6 is pointed to the next location, and R3 value will be R3 value. What's the R3 value? R3 value is 12. So 12 will be moved to the R6 location. And again, we are coming back to the starting position, the next position, and first comparison is over. Next, we will decrement the comparison R1. Now the R1 value is 3. Okay, and since it is not 0, again we are performing this iteration. Now, till R1 becomes 0, the first iteration will be completed, and the first data set, after completing the first iteration, the data arrangement will be 1 2, 2 4, 2 3, 1 1, and 8F. Okay, so now again what we need to do, again we need to start from starting in order to get the second highest number in the second position. So what we do again, since R1 becomes 0 0, we are coming out of the loop. Again, now we subtract R0 by 1. Now the number of comparisons required will be only 4. Number R0 will be 4. And then since R0 is not equal to 0, again we will be starting the, if R0 becomes 0, we are coming out of the loop. If R0 is non-zero, again we are going to start from top 2. So again, from here, the control is going to transfer to this location. So by this, by the end of this program, we will get the ascending order. A small change, by doing a small change, we can get the descending order also. That is, instead of comparing R2 and R3 for the data exchange, if we compare R3 with R2, so what happens then? If we are doing the R3 with R2, then the smallest number, if the first number is the first number is smaller than the second number, then the data exchange will occur. Okay, so by this we will get the descending order format. Okay, so the next program is your descending order. I will show you. Everything will be the same, only a small change we can make, and this is where the changes occurred. R3 with R2. Okay, so now these two programs we will try to implement with the Keel software. So open your Keel software, select the new project. I'm making it as project 2, and select the legacy database, and then STM32F401RE. I've selected the device. If it is there, don't panic. So you can get overwritten. So open that startup file and disable the initiations as usual you do for the other programs. How you do for the other programs. Okay, then you open the text file and write the program. Since I have the program, I'll directly open the program, D and E, right? Uh, I'll take this start. Okay, now you have to add this program to your project. Yeah, now it is added. Then, yeah, export export labeling. You identify the export labeling because this is the most important thing. So import, yeah, you exchange it, you store it here, then come back to the program, save it, then build. Okay, so see here we are getting 0 errors, 0 warnings. Now you can go for the debug mode. Okay, so in this debug mode you can start debugging by using F10 first, because you need to identify the locations where your destination is being there. Okay, so your destination is pointed by R6. So your destination is 2000000. Okay, so now you start doing the things. Now see here carefully how the data has been stored. So first data has been stored, then the second data, then the third data, then the fourth data, then fifth data. That's it. So now data exchange has been over. Now you are doing the comparison operation between 8F and 12. Okay, so now see here again length is being assigned as 5, 1, add, LDR, compare, right. So by the time you finish it, you'll get the sorted data out. see here. Yeah, R1 now R has become 4, 5, 6. By the time R1 becomes 0, okay, your result is ready, and where we have to check the result. Okay, so into your destination location you have to check. So destination location is pointed by R6. So you check your R6 value. Okay, so you'll get the descended order program. Okay, so now if you want to make it as an ascending order, so make it as come out of the loop. Okay, and then make it as R2, R3. Yeah, I made it mistakes. Okay, no problem. So now if you see, if you build it again, if you debug it, okay, straight away running the program so that I'm stopping. So this is where so see here, the data has been arranged in an ascending order. Okay, so like this you can do the programs ascending as well as descending order. So try with the different datas and try to finish the things, right? That's it for the day.